What's up guys, it's Simon Fiaz and today's video is on AQA A-level chemistry periodicity question paper. So you can see I'm trying to get these question papers out of the way from PMT and then move on to the difficult questions from the past paper and the PMT questions, and plus also just constantly reviewing the content with you guys. Question 1, which element is classified as a D block element? D block element is in the middle of the periodic table. So if you imagine this is the periodic table, that's S, that's D, that's P, and that's F. It's not SPD, it's SDPF. So if I go here, look in the middle, you guys see the periodic table as you can. Okay, what was my options? Antimony, let's look for that. Let's have a look for that. Can I find that? Can I spot that? I cannot. Where is antimony? There it is. It's in group 5, so it's not in the D block element, it's a P block. Molybdenum. Perfect, it is in the middle, it's molybdenum. Which element in period 3 has the highest melting point? Aluminium, silicon, sodium, and sulfur. Well, let's think about it. Sulfur, S8, no. Silicon, no, because aluminium, it's going to be aluminium because it's a metal and therefore it's got metallic bonds. That's simple. And yeah, but Iman, so is sodium a metal? Yes, but sodium is Na plus, aluminium is Al3 plus, so it's got a greater charge, stronger metallic bonding. Which ion has the largest radius? Just memorize this key fact. Negative ions have a larger ionic radius than positive ions. So just by using that key fact, I can cross out the positive ions. They're going to have a smaller ionic radius, but the more negative ion, the more larger ionic radius, so it's going to be O2 minus, therefore D. Question 4, which element has the first ionization energy lower than that of sulfur? Sulfur is there, just below oxygen. I know first ionization energy decreases down the group, so it is going to be selenium. It has a lower first ionization because that's lower than that. When a piece of sodium is added, 200 liters of water, given the equation for reaction sodium with water. So the equation, 2Na solid plus 2H2O liquid to form 2NaOH aqueous plus H2 hydrogen gas gaseous. Suggest why it's dangerous to react a small piece of sodium with this much. Reactants can shoot out of the tube. Given equation for reaction phosphorus 5 oxides of P4O10 with water. This is the equation you have to memorize, plus 6H2O. It doesn't ask me for state symbols. In this case it did, in this case it doesn't, so I don't need to include it. So then 4H3PO4. Suggest pH for solution formed -1. Explain in terms of crystal structure and bonding. Silicon 4 oxide has high melting point of phosphorus 5 oxide. Silicon dioxide is macromolecular / giant covalent. Strong covalent bonds needed. Strong covalent bonds between atoms which need a lot of energy to be broken, whereas P4O10 is molecular, weak van der Waals forces between molecules. Element in period 3 forms an oxide as insoluble in water, oxide reacts with sulfuric acid, and with aqueous potassium hydroxide, give the formula as oxide. This is a beautiful question. Like it shows you how they can test you in just tiny details, but also how you need to apply it. Well, what is sulfuric acid? It's an acid. What is potassium hydroxide? It's a base. It's an alkali. And what do you call it? Amphoteric, and which is the one that you need to know in periodicity? Aluminium oxide. And then the reaction with this was sulfuric acid, Al2O3 plus 3H2SO4 to form Al2SO4 3 plus 3H2O. Give a formula of a hydroxide of element period 3 used in medicine. Magnesium hydroxide. Identify the element in period 3 from sodium to chlorine that has the largest atomic radius. This one's a bit tricky. Well, if we think about it, sodium to chlorine. I'm going to have a look here. Sodium to chlorine. Well, a lot of students, including myself, would say chlorine. It's got the most number of electrons, right? But it's also got the most number of protons. And what do I know? First ionization energy increase across period. Is it asking about the first ionization energy? No, but this somehow links to it. And the first ionization energy increase across period, right? But actually, no. Yeah, first ionization energy increase across the period. So across the period, atomic radius is going to decrease because in order for first ionization energy to decrease, you want number of protons to increase, high nuclear charge, shielding is similar, and atomic radius decreases. That's what you want to happen. So atomic radius decreases across the period. So therefore, the one with the largest atomic radius is actually sodium, because if it decreases across the period, magnesium has a smaller atomic radius than sodium, aluminium has smaller atomic radius than magnesium, etc., until chlorine. So therefore, sodium has the largest atomic radius in period 3. They could ask you for this. They probably wouldn't ask you this for like other periods. They would probably just ask you them for period 3, group 2, and group 7, because those are the 3 major topics that you need to memorize that appear in the specification. So yeah, just be aware of that. The general trend for an increase in ionization energy across period 3. Give an example that deviates from this trend. Period 3, again, across period 3, from sodium to chlorine. Well, I could talk about sulfur, but let's talk about aluminium. If I draw out the structure of aluminium, 1s2, 2s2, 2p6, 3s2, 1012, 3s2, 3p1, whereas with silicon it's 3p2. So silicon's actually, so aluminium, whereas with magnesium it's 3s2, not 3p1. So aluminium is an example of an element deviates from this trend because its outer electron is in a 3p orbital. You have to state which kind of orbital it is. Don't just say in an orbital, or don't even say in a p orbital. In a 3p orbital, and 3p is higher in energy / further away from 3s. Given the equation includes say some of the represent third ionization energy of sodium is measured. In this case you need to know the trick. Subtract 1, so Na2 plus gaseous, arrow Na3 plus gaseous, plus E minus. Part C. Identify element X. Element X. Okay, element X is this. I think it's got at least 10 electrons. The big jump in ionization energy is here. So therefore the element must be element in group 5. So if I go to group 5, it's got to be in group 5, and it's also got more than 10 electrons, and it's in period 3, so it's got to be phosphorus. It's in group 5 and period 3, yeah, it's phosphorus. So therefore the element is phosphorus. So that was a bit tricky, but all you have to do is memorize a key fact. When they give you this successive ionization energies, when one electron is being moved from each outer shell, where the jump is, so you see here's a massive jump. From where the massive jump starts, from the 5th, that's what its group number. That tells you, that indicates the group number. Memorize that, and you should be pretty comfortable with these kind of questions, because that's all they really want to assess you on. And then explain your choice. Well, this case you can't just say because it's got this many electrons, but you need to say first things first. It's only 2 marks. You say large jump in ionization energy, which that is. Large jump in ionization energy for the 6th ionization energy, as this is when the electron is being removed from an energy level that is closer to the nucleus. I would write that down because this is something I could memorize and I could use this general statement for any kind of question. In this case, large jump in ionization energy for whichever ionization number, the 6th ionization energy, and then because electrons are being moved from energy level that is closer to the nucleus, which represents the correct order of increasing radius of the ions. Now, very similar, I guess, to this question, which ion has large radius. Just slightly different, but I'm still going to use the key fact that I told you guys to memorize. The idea that negative ions have larger have a larger ionic radius than positive ions. Negative ions have a larger ionic radius than positive ions. But this case says increasing radius, so therefore the negative ion is going to have the highest one, the large ionic radius, so it's going to be in this case, so it's going to be here. So therefore the answer must be C. Yeah, it must be C. Question 8. Which of these elements have the highest melting point? Argon, chlorine, silicon, or sulfur? Argon, Ar, chlorine, Cl2, sulfur, Sa, or silicon. It's obviously going to be silicon. The draw constant graph to show the second ionization energy for silicon. Now, what I would do is I would quickly draw the structure of aluminium. So aluminium is 13 electrons. It is 13 electrons, therefore it's 1s2, 2s2, 2p6, 3s2, 3p1, 4, 10, 12, 13, whereas silicon is 14. So silicon is 3p2, right? So silicon's second ionization energy is going to be between magnesium and aluminium. Yeah, because these are second ionization energies. So it's actually going to be slightly lower, like somewhere here, like 1580. Here, here, and then there. Should you learn these graphs? Because there's only two they could assess you on. The period 3 and the group 2 and group 7, right? Oh, sorry, yeah, period 3. So, yeah, just have a quick look at it. If you can memorize them, perfect. If you can't, that's fine. Identify element period 3 for sodium to argon that has the highest second ionization energy. Sodium to argon, period 3, highest second ionization energy. How would I do that? How would I do that? Well, I know atomic radius increases across a period, and I want to know the one that has the highest second ionization energy. It's going to be sodium. Just like before, if I can find the previous question, it gives identify element of sodium to chlorine has the largest. No, atomic radius decrease across the period. The largest atomic radius is sodium. Identify the element in period 3 from sodium to argon that has the highest second ionization energy. Identify the element in period 3 from sodium to argon that has the highest second ionization energy. But sodium has the largest atomic radius. So sodium has the lowest first ionization energy in group period 3. Yeah, okay. So sodium has the lowest first ionization energy. Sodium has the lowest first ionization energy in period 3. But if I draw out the structure of sodium, 1s2, 2s2, 2p6, 3s1. It's 11 electrons in it, isn't it? Yep. So the first ionization energy will remove this electron, the 3s1 electron, easily. That's what has the lowest first ionization energy. But then once that's happened, the second ionization energy, moving a second electron, you'd have to pull an electron from a fully stable 2p orbital. Fully stable 2p orbital, and therefore it's going to require a large amount of energy to overcome. Therefore, it's going to have the highest second ionization energy. And then identify with second ionization energy. Second ionization energy, just do the opposite. So Na plus gaseous arrow, Na2 plus gaseous plus E minus. But don't worry, guys, if you like are not fully getting this, because they probably are going to reuse this kind of question, because there's only so many questions they could ask you. The atomic radius decreases across the period from sodium to chlorine. Well, it decreases. Well, in order for it to decrease, well, which it does, first ionization energy increases across the period. Atomic radius decreases. Sodium has the largest atomic radius. Chlorine has the smallest atomic radius. Okay, from sodium to chlorine. But why? Because the nuclear charge, or the number of protons, increases and shielding is similar. Electrons, or you could say electrons, are being added to the same shell, or same number of shells. Identify the element from period 3 from sodium chlorine that has the highest electronegativity. Highest electronegativity. What is the definition of electronegativity? Let's break this question down. The power of an atom, because you really want to understand these questions, because then when they repeat them, and they just tweak it up a bit, you know exactly what to do. But if you learn them off by heart, and then it's unlikely they'll use the exact wording. So you need to understand the question in this case. Power of an atom to attract a pair of electrons in a covalent, power of an atom to attract a pair of electrons in a covalent bond. Okay, so what do I know the general trend for sodium to chlorine? I know atomic radius decreases, so I know the radius decreases. I also know nuclear charge, or the number of protons, nuclear charge increases. And I also know first ionization energy increases. So which one has the highest electronegativity? The power of an atom to attract a pair of electrons in a covalent bond. So first ionization energy is the amount of energy required. I forgot the definition now. But it's to remove the electrons, right? So which one's going to have the highest ability to attract a pair of electrons from sodium to chlorine? Chlorine. And I'll tell you why. Because chlorine has the highest nuclear charge. It has the smallest atomic radius. It has the highest first ionization energy. But that's not really relevant, I guess. But that all means is that the electron outer electron is closer to the nucleus, and therefore the power of an atom to trap the pair of electrons in a covalent bond is easier. Therefore, has the highest electronegativity. Because if something has a high electronegativity, that means it can attract a pair of electrons. It has a high power to attract a pair of electrons. So therefore, the atomic radius is really small because it has a high power to attract a pair of electrons in a covalent bond. So hopefully you guys understand that. Phosphorus burns in air to form phosphorus trioxide. So P4 plus 5O2, P4O10. Yep, don't need state symbols. State the meaning of the term periodicity. Periodicity. One marker, state. Repeating patterns / trends of physical or chemical properties. Repeating patterns / trends of physical or chemical properties. Identify the element period 4 with the highest electronegativity value. Never mind, they can attack different periods now. So they did period 3, and now they're doing period 4. But don't be be bewildered. Just apply the same logic. Identify element period 4 as the highest electronegativity value. So period 4, well, that's period 3 from sodium to chlorine. So period 4 is potassium to bromine. Perfect. Okay. Which one has the highest electronegativity value? So what do I know about the thingy? I know that same thing applies. Across the period, atomic radius decreases. Nuclear charge increases because number of protons increases. Similar shielding, but I ain't gonna write that down. And therefore, first ionization energy increases. Okay. First I dot E increases. So electronegativity is the power of an atom to attract a pair of electrons in a covalent bond. So if it's going to have a high electronegativity, it's going to be able to attract a pair of electrons in a covalent bond easily. It has a high power. So like, think of it. If you have a lot of power, you can get things kind of easily, right? Same electronegativity. It's got a high electronegativity, so it can attract a pair of electrons in a covalent bond very easily. So therefore, which one's going to be from potassium to bromine? It's going to be bromine because bromine has the highest nucleus charge, smallest atomic radius in period 4, and therefore can attract the pair of electrons very easily, therefore has the highest electronegativity value in period 4. Bromine. Identify the element period 4 with large atomic radius. Now I know atomic radius decreases across a period. So the one across a period. So the one with large atomic radius is obviously going to be potassium. Now the explanation is obviously going to be slightly difficult, but it's just the idea that it's got the smallest nuclear charge, smallest number of protons, and similar shielding / same number of shells as other elements in period 4. So it's got the same number of shells as other elements in period 4, but it's also got the smallest number of protons, smallest nuclear charge. It is going to have the largest atomic radius. I really hope you guys understand that part, because these type of questions they love to ask. Identify the element in this. Name the property of arsenic 3 oxide. Describes the ability to react in 2 ways, where it acts with an acid, hydrochloric acid, and a base, sodium hydroxide. So it's obviously going to be called amphoteric. Complete the equation for the formation of arsenic hydride. 6Zn, 12HNO3, 2ASH3, 6Zn NO3 to 3H12. I'm gonna create. I did say to you guys a video where I'm going through these kind of extremely difficult completing the equation, advancing equation kind of questions, and how to attack them. Diagram. Diagram shows how property periodicity elements vary across the period. What is a property? Varies across the period. Well, period 3, I know property that varies across the period. I know atomic radius decreases, right? Consistently, the atomic radius decreases. I know the electronegativity increases. I know the first ionization energy consistently increases. But what is it that, so therefore it must be melting point, but it makes sense because that's sodium, Na plus, that's Mg2 plus, then Al3 plus, then boom, silicon, but then you've got phosphorus, and then it slightly increases because you go from P4 to S8, and then it massively decreases because you go from S8 to Cr2, and then it goes there to argon, which is monatomic. So yeah, it is melting point. Melting point. Which element has highest first ionization energy? Aluminium, phosphorus, silicon, sulfur. Where are these? Aluminium, phosphorus, silicon, sulfur. Highest first ionization energy. Well, first ionization energy increase across the period. Atomic radius decrease across the period. But the thing is, sulfur has got the lone pair electron repulsion, so therefore it's going to be phosphorus. Now, the reason I know that is because they always love that idea that sulfur's got the paired electrons repel. Yeah, I think it's that. And then therefore lower first ionization energy. But yeah, the answer is phosphorus. Which of these period 3 elements has the highest melting point? Aluminium. How do I know that? Because that's a metal. Phosphorus, no. It's intermolecular. Sodium. Sodium's also metal, but it's only Na plus, and that's Al3 plus. And sulfur, same thing as phosphorus. Which is the correct order melting points of these period 3 elements? Phosphorus, sulfur, chlorine, argon. Definitely not. So correct order, so hence meaning it's increasing. Wait. That's a bit tricky now. Let's go through it again. Sulfur has a higher melting point than phosphorus. Yes. Sulfur has a higher melting point. No, phosphorus has a higher melting point than sulfur. No, that's not true. Argon has a higher melting point than chlorine. That's not true. Just need to spot one. Sulfur has a higher melting point than phosphorus. That is true. Phosphorus has a higher melting point than chlorine. That is true. And chlorine has a high melting point than argon. Yes, that is true. And let's look at D. Chlorine has a high melting point than phosphorus. Definitely not. And then you can cross it out. So yeah, C is the correct answer. Which is the correct classification for the element yttrium? Y. So I'm just gonna have a look in the periodic table for Y. That's what I'm gonna do. Just start from the top. Helium, neon, argon, fluorine, sodium, magnesium, aluminium, silicon, krypton, boron, bromine, selenium, arsenic, rubium, strontium, yttrium. There we go. So it's in that group 3. Well, it's in the middle of the periodic table. And remember, if you just do a quick sketch of the periodic table here, that's your S block, that's your D block, that's your P block, that's your F block. Yttrium is somewhere here. It's in the D block. So it's in the D block. You need to be able to be confident with identifying which is S, which is D, which is P, and which is F. Which of the following is a correct statement about the trend in atomic radius across period 3 of the periodic table? Atomic radius decreases. I know that because I literally have memorized that fact. The atomic radius decreases across period 3. So radius increases, no. Radius decreases, yes. Radius increases, no. So obviously it's not going to be that easy. I can cross all of them out because both of them says, all three of them says increases. No, two of them says decreases. So I need to identify what is the correct reason. Radius decreases because nuclear charge increases, or the radius decreases because shielding decreases. Radius decreases because nuclear charge increases. Yes, that is absolutely true. You could definitely fall for D, but just don't fall for it. Which element is in F block of periodic table? Quick sketch again. S, D, P, F. So the F block is here. What I would do is just look at each one. So palladium. Actually, no. In this case, I know it's in the F block, so I'll just go to the F block and I'd have a look. So I'll start off with palladium. Is it in the F block? No, it's not. Phosphorus, definitely not. I know it's not that. Platinum. No. Plutonium. It must be plutonium, and there we go. I can spot it as well. Plutonium. So that is the key skill. Question 18. Which elements are shown in increasing order of the stated property? Atomic radius, phosphorus, sulfur, chlorine. Atomic radius, phosphorus, sulfur, chlorine. No, atomic radius decreases across the period. And that's for period 3, so no. Decreases across a period. Across period 3, let's be more specific, because they're only going to ask you in period 3, and you have seen the example where they've asked you in period 4, but I think those are the only two periods they could ask you about, really. I guess, yeah. First ionization energy, sodium, magnesium, aluminium. Does ionization energy increase across the period? Yes, it does. But. Magnesium, aluminium. Magnesium, 12 electrons, 1s2, 2s2, 2p6, 3s2, and therefore aluminium is the same thing, but it's got a 3p1. So aluminium actually has a lower first ionization energy than magnesium because the outer electron is 3p orbital, and 3p orbital is higher in energy / further away from the nucleus. So it's actually not B as well. So yeah, that caught me off guard. Definitely that would catch a lot of students, including myself, off guard. So I'm left with C and D. Electronegativity, sulfur, phosphorus, silicon. Sulfur, phosphorus, silicon. So they've gone in reverse order, but I know that electronegativity increases across period 3 because the nuclear charge increases, atomic radius decreases. So the definition of electronegativity, the power of an atom, or the ability of an atom to attract a pair of electron covalent bonds, increases because the electrons are closer, outer electron closer to the nucleus, so they can be pulled in more easily. And remember, if you have a lot of power, just in general, you can get things quite easily. So the atom can attract a pair of electrons and covalent bond quite easily. Therefore, it's got high electronegativity. Now, with sulfur, phosphorus, and silicon, well, I know electronegativity increases across the period. So if I'm going backwards, well, then it's going to be decreasing, not increasing. So no. Melting point, it must be melting point. And if you look at melting point, argon, then chlorine, yes, and then sulfur, perfect. Yeah, melting point does increase it across period 3. It is period 3, right? Argon. Yes, it is. Which of these elements has the highest second ionization energy? Now, sodium, magnesium, neon, or argon. They just pulled these two out of nowhere, but I'll look at these later. Sodium and magnesium. Sodium has the highest first ionization energy. No, sorry. Sodium has the lowest first ionization energy. It does, because it's got the large atomic radius. I know atomic radius decrease across period 3, therefore sodium has a large atomic radius, and it's got smallest number of protons. So it's actually got the lowest first ionization energy, and therefore it has got the highest second ionization energy. And if you think about it, sodium, 11 electrons, 1s2, 2s2, 2p6, 2, 4, 10, 4, 10, 1s2, 2s2, 2p6, 3, 2p6, 3s1. This can be easily removed, but then you need to remove the second electron from this 2p6 orbital, and that's fully stable. Fully stable, therefore it's going to requires large, really great number of energy to overcome. I don't know why I did that symbol. I think it means large, but I don't know. Therefore, sodium has the highest second ionization energy. Explain what atomic radii of the elements decrease across period 3 from sodium. Chlorine. Well, I know the atomic radius decrease across sodium to chlorine because nuclear charge increases, number of protons increases, attraction between the nucleus and electrons increases as the electrons are in the same energy levels, same shell / number as shell. Question 21, explain multiple points sulfur is greater than phosphorus. Very nice question. Let's talk about the size of the molecules. Sulfur molecules are bigger than P4 molecules. Hence, van der Waals forces between molecules are stronger in sulfur. Sodium oxide forms an alkaline solution when it reacts with water. Sodium oxide, well, therefore it contains O2 minus ions. So sodium oxide contains O2 minus ions. Hence, these O2 minus ions react with water, because it tells me it's reacting with water, forming OH minus ions, which therefore means it's alkaline. That's very difficult. Sodium oxide, Na2O, it's got sodium ions, O2 minus ions. Sodium oxide contains O2 minus ions. These O2 minus ions react with water, forming OH minus ions. Write an equation for the reaction phosphorus oxide, P4O10, plus sodium hydroxide solution, 12OH minus, to form 4PO43 minus plus 6H2O. Perfect. And again, this is an equation you should memorize. And that's the end of the periodicity question paper.